Oh, you can tell I'm totally practiced at doing this streaming malarkey, can't you? Got to unmute the mic, that might help. Right. Hopefully the audio level is okay. Seems about right. Let's crack on. So, what are we going to do today? Well, we're going to start. Where are we going to start? Honestly, there's so many different places we could start. I'm just gonna pick one. I haven't even worked it out where I'm going to start in my head, so we're going to try and work out where we're going to start in this video as well, because there's so many things we could be doing. Let me just see if I can bring up this architecture thing that we drew yesterday. Here we go. There we go. So, where do we start with all this? One of the thoughts I had is that any good architecture that allows you to defer decisions to a later date is a good architecture. So we could start with user interfaces, or we could wait 6 months for the state of user interfaces to be improved by the people that are writing the UI tooling. It's an option. Don't necessarily need to delve straight into doing UI stuff right now. And to be honest, it probably needs a little bit of experimentation with some of the different UI libraries that are out there. So I'm feeling that I don't want to start with the UI straight away. I probably want to think about planning what the UI is going to look like and doing some UI mock-ups and things like that. So let's skip the UI for now. Then one of the other things that I want to try and improve on this project is the workflow. So perhaps the workflow side of things is a good place to start. We could go straight down and doing the nitty-gritty detail of having a machine that runs jobs and all this kind of thing. There is also the point that I've not been doing a lot of Rust code for the last 6 months or so, so I'm going to be rusty at it. So I don't want to delve straight into super complicated machine job processing code before I remember all the things that I've forgotten over the last 6 months and it all comes flooding back to me. So perhaps starting on something slightly more simple, such as where you start with from your pick and place machine software and your EDA tool, and the outputs that they give you, and then see if we can work out some form of like defining an assembly variant, how you come up with them, and start around there. It seems useful. Plus, even if I can come up with some stopgap interim solutions to allow some manufacturing without the whole system, the workflow improvements and generating files and all this kind of stuff might still be useful anyway. So let's start with EDA inventory assembly variant related stuff. All right, so we're going to be using Rust to do it. And we've got an IDE. We're using the new Rust Rover IDE by JetBrains. The reason that I'm using the JetBrains tooling over, say, VS Code is because of the refactoring facilities that it offers. It's just very, very, very good. When I first started using IntelliJ like years ago, and I was used to using Eclipse, I didn't get on with the user interface, but then I used it more, and then I realized how powerful the refactoring tools were in the sort of day-to-day sort of operations and coding side of things, and was sold on it. And over the years, it's got better as well. The UI has. They've recently done a new one. Anyway, so let's just start. Here we go. We're going to do a new project. It's going to be amazing. Right, where are we going to put it? I'm going to find my document for dev. Here we are. Projects. And I created a directory, MakerPnP. Here we go. We're going to put it there, and we're going to call it got to name things now. I don't know. Let's just start with MakerPnP. Sure, why not? Yeah. Tool chains. MSVC. Yeah, okay. We're doing a binary. Everything's fine. Create. Do a new window. Let's get rid of this one. Make this one bigger. Right. So we've got a new project. First things first, let's make sure it works. Hey, it works. Okay, so dependencies and all this kind of thing, and what are we trying to do? What are we trying to do? Let's bring up the EDA tool for a moment. Yeah. Okay. Right. We're going to create this dip trace. We're going to do a random new project. We're going to... Where's my... There it is. Okay, MakerPnP. Right. So let's create an assets folder or resources. Now, let's just create, because I'm trying not to use the directory names that are used by Rust projects. So we'll examples, for instance. We're just going to go EDA dip trace. Yeah, that's probably enough. And we'll call it example 1. Okay, fine. So we're just going to do some stupid circuits. We're going to find an SMD cap. We don't really care about any of this, sort of like the detail of this. And we're going to have, we need some form of power source, which I believe is under the net ports. Here we are. We're going to say a 5-volt power source. Great. And we want a ground. And we've got a ground. Fine. Right, great. Then we're going to have a resistor, a couple of resistors and a couple of LEDs, which is what we're going to try and do here. And then we're just going to create a little board with these on, such that we can have the board populated with different circuits. Resistors, chip, metric. Inch, yeah. Okay, we'll go 0402. Everything's fine. Oh, I'll tell you what, I'll do the other one first. And we'll go for LED optical sensors, LED SMD. Yeah, one of these will do. Sure. And then anybody following this will then have an idea of what's going on, why we're trying to do all this. Right. So we're just going to do this. Okay, great. Amazing. So we've got our schematic. Let's just change the title and sheet setup. Let's make it A4. It's a bit big. There we go. Sure. Amazing. So we've got that. Right. Now we're going to do a quick PCB layout. Yeah, come on. Come on. There we go. Let's make that the right size. And then we're going to say save as. We're gonna. Oh, I can't steal the path from the title bar. Hold on. Let me bring up. Oh, no, not that. This, that, this. Okay, good. Fantastic. Copy that to the clipboard. PCB layout. Paste that in there. Call it example 1. Right, great. And then we're going to go layout information. We're going to link it to the schematic. And then we're going to update it. Right, fantastic. So we've got all our parts here. And we're just going to create a PCB outline. Let's set a grid of 5 mil. Seems reasonable. One thing we are missing, mind you, is a connector. Let's just headers. There's so many things. Connectors, headers, whiteboard, 2.54 mil. One of these. I want a 2-pin one. No. That one will do. Here we go. Right. Let's go back into schematic land and update that. There we go. Now we've got our connector. That's quite chunky, isn't it? All right. Let's go on a 1 mil grid. And let's just quickly route this. So we don't really need to route this, but you know, whatever. Probably could press the auto route button at this point, but you know. Yeah. Oh, yeah. Hold on. I don't really know why I'm routing this right now. It probably shouldn't be. But you know. Probably should align these a bit better, but what am I going to do? Okay. You know. Amazing, we've got a board. Save that. Right, enough of that. We can, just so that people can see this, you can look at a 3D view of it as well. Amazing. That's our stupid LED board. Right, so you could do assembly variants of this where you populate all of the LEDs or you don't populate the LEDs and so on. So we're gonna export pick and place files for this. And this is what we've got. Ref des, name, pattern width, yada yada yada. Right. It's only a single-sided board at the moment. Thinking about moving on to the other side, but this will do for now. Let's keep it simple. Let's keep it simple. Right. So we're going to export this. Big place. Export to file. And hopefully it's still in the clipboard. Yeah. And we're going to go example 1. P and P. Right. Fantastic. So if we go back into our IDE, we should now be able to see these files I've just created. And I've got this. But I'm missing a plugin here. Let's add that plugin. This one. Okay. Restart. Do, 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 do. Do, 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 do. Where'd it go? All right, there it is. Right, so we can see what we're working with. So assembly variants. Now in DipTrace, I've never used this feature. We're just going to have a quick look at the EDA tool, because the EDA tool these days has some support for assembly variants. Probably not going to use these because it doesn't really fit with the whole inventory management workflow thing that I was talking about. So in here, there's this concept of assembly variant, right? So you can go how do you do it? Add. Okay. Right. So we have 4 assembly variants for this. One where everything's populated. Okay. So in this user interface is fairly reasonable at this point. And thus, so we either populate one LED circuit, the other LED circuit, or the other LED circuit. Let's go back to the schematic for a moment. Just check the ref deses. So R1 goes with D1, R2 D2, and R3 D3. Okay, so we've got one assembly variant with R1 and D1, another one with R2 D2, another one with R3 D3. Bus is always populated on all of them. The the connector is always populated on all of them, and then we've got another assembly variant where everything's connected. So these are assembly variants, fine. So when you're exporting these, it probably and we'll just use the same numbers. We're just going to export them all. I wish it wouldn't close that dialog after you export it. There we go. And we're going to have a look in the IDE just we do this. A bit manual, this process, which is the reason why I don't really like this. Plus also it's got no idea what stock you've got, and we haven't even... Oh, yeah, okay, well, I'll come to that in a bit. Fine. So if we go back to our IDE now, here we go. We've now got the original one that we exported, which contains everything, which should probably be the same as this one, which it is, which should also probably, and then all the other ones are going to be different. So they're going to be like this, right? So for anyone sort of not familiar with assembly variants. That's the general concept of an assembly variant. But in each EDA tool, the process of creating assembly variants is going to be different. And each EDA tool is going to have no knowledge, in the case of dip trace, or some knowledge of components that you might have in stock. Dip trace doesn't have any integration, certainly in the schematic side of things, with part libraries that you might have on hand. It doesn't know about your stock levels or anything like that. Okay, so we're going to turn on a few things in here for a moment. Where is it? Part marking. Name, like so. Right. Okay. So we haven't specified sort of which one's red, which one's green, and all the rest of it. These things have got footprints attached to them, thus. And there's other LEDs that again fit on that same pattern. So it's currently got this here, but there'll be another LED that will fit on the same footprint. And with a resistor, you know, we haven't even specified this. Let's just say 330 ohms. I don't know, let's make this one 470 or something, I don't know. Oh. Yeah, okay. Okay, so we can save that. Go back to the schematic, and this is where things start to be tedious with all this. And then we update the schematic. Fine. But now it means we have to re-export all the pick and place files. So we're just going to do the main one, the default one, for now. I'm going to delete these because they're now out of date. Whatever. Right. So we've got our value in here now. This is the important bit. And we've got a name, which is res 0402. Right. What's also missing from here is the manufacturer. Now, you don't care when you're doing the schematic who the manufacturer is of your resistors and LEDs, really. Some things you might care about the manufacturer, but you know, for like a headed connectors and things like that, you know, you go on LCSC. Where is my LCSC? Oh. And you know, you search for 0402 300 ohms. Oh, 330 maybe. All right, and there's many resistors. We're just going to randomly find a couple. R resistors. Here we go. We're going to sort by in stock. 0402. In 30 ohm. Oh, that's kilo ohms. Don't want that. Here we go. Getting there. In 30 ohms. Okay. And apply. And let's search for the one there's most of. Right, so we've got Jaeger ones. So fantastic. So there's other ones which we could use. Let's go back into this. So we know we want 330 ohms. We know it needs to be A402 size because it's got to fit on that pattern. Other than that, we don't really care. So let's have a think. Okay, where are we going to start with this? Do I want to create workflows? No, we'll arrange everything a little bit later, I think. Do we do it now? No, we'll do it later. We'll do it later. We're just going to create a new Rust file called. Oh, what are we trying to do here? Let's just call it simply. Okay. Right. Rust syntax. Brain needs refreshing badly. Real bad. Let's bring up this guide. There we go. No, not this. Here we are. No. Oh, there's yeah, this one. Yeah. Right. Yes, if you've not done Rust and stuff before. Oh dear, where is it? That's what I was trying to write. Structures. So defining structures is what we're trying to do. That's syntax for defining structures. I don't see why I couldn't find it in here somewhere. Structs. There we go. There it is. I couldn't see it for looking. Right, defining structures. So we've got this. Yeah. What are we going to do? Yeah. Okay. Let's start with a test. Oh. Whatever. A good way of naming tests is at the end when you've written it. And I prefer writing tests with the given when then style. And when I'm writing a test, I start with when. So if we say I want to pick all the components matching for an assembly variant. This is going to get a bit funky, this is, because we don't sort of really know what we're doing, but I'll probably be able to formulate a few more more coherent thoughts as we progress with this. If we say I want to define an assembly variant and then have it process the list of things that we've got so that it reduces it to match the list of things that's supposed to be in the assembly variant. Let's start with that. So we've got our things. We haven't named these yet. And we know that we need to define some way of creating an assembly variant. And then we're going to have to go for this assembly variant, what parts that are in stock that I have here can I make it with? That's sort of what we're trying to come up with. So when we say assembly variant processor. Let's just say process. Honestly, I don't really care right now. Right. So we need it to process some things. So these things are probably going to be called placements. And we probably need a definition of a variant. Okay. So, oh dear, look at this. Semicolons. Right. When we do this, then we expect there to be a list. Right, so result. And I suppose we need to assert that the result is what we want. Yeah. Okay. Yeah. Right. So expected result. Def. Been doing groovy too much. I don't know. Let's say we want to. It's going to be okay, and it's going to contain some stuff. What's it going to contain? It's going to contain. Let's look at the list. It's going to contain a bunch of placements for sure. You could use tuples for this. Let's just go processing result with placements. This seems reasonable. So let's create a struct for processing result. Now, Rust wants you to create things in a particular way, so we'll do that. And this is one of the great things about Rust. There's certain ways of naming things which are standard across all Rust code bases, which is another reason why it's really nice. So yeah. And this is going to be... oh yeah, we'll get to that in a moment. Yeah, we're going to have to do that. Processing result. Okay. And this is one of the reasons why I like doing, coding in IntelliJ, because you just do things like this and it just magically does it. I'm just pressing Alt-Enter on anything that's red and it comes up with a list of stuff that you need to do. So we need to give it some placements. And this is going to be fun. And it's going to go... Right, but we don't know what this placements really thing is, really. What is this going to be? This is going to be... We're going to use some collections. There's a bunch of different collections. Vec is the normal one. So let's just go with that until we can't. So we're going to say it's a vector of placement like this. So that means we need another struct for placement, right? So fine. This doesn't appear in the thing, so we're just going to create a field. Magic. Look at this. Okay. Variant placements. We don't have one of those yet. So let's create. Then we've got to look up the Rust literal vector syntax. Oops. Oops. That one. Yeah, man, I'm really rusty. It'll all come back to me. Why am I vectors? Yeah, that's what I'm looking for. So use the vec macro with square brackets to do it. So yeah. Because I was doing loads of stuff in embedded stuff, and you don't use a vec at all because memory allocators. Good lord, what a luxury. Okay, so we're going to have placement 1, placement 2, placement 3. Let's just say 3's a good number, 1's not enough, 2's not enough, 3's probably a good number. Now, it still can't help us because it doesn't know what the type of vectors is, so we're just going to say this is a placement. And we're just going to say new. And we're going to give it a refdes, because all placements always have a refdes. And we're going to say it's going to be R1. And that's going to be enough for now. Yeah. Right. And then we've got to deal with strings and things like this now. This is going to be it's going to be fun. Why? Okay. Oh wait, hold on. That's better. Look at this, and it helps you. You don't even have to worry about it. Brilliant. So we're going to say ref des. I'm not quite sure why it's. Oh, I see. Yeah, it's fine. It doesn't know that we're creating one of these. I'm going to take these off for now. String reference. Self. Ref des. And then now the problem we're going to have here is lifetimes. Do I want a stir, or do I want something else? Yeah, I haven't done much stuff with strings in Rust. You'd think, after spending 2 years writing code, you'd know how to use strings in the language, but it turns out that when you're writing embedded code for flight controllers, you don't use strings very much. So my knowledge of the string API library is subpar. So you can create strings in 2 ways. There's string as a vector of bytes, or you've got a string reference. I think we want to have strings like this type of string, rather than the reference, because as soon as you start using reference in a structure, it means your structure has got to have a lifetime as well. And I don't really want to get into the whole lifetimes of things right now. Not for this. Not just yet. So instead of that, we're going to say string. And then we're going to fix the other thing later. Which is going to be moaning about this. Right, there's no typo in refdes. So we're going to add that to the dictionary. There we go. Right, it's moaning about this. Oh, let me go back to this. You can create a new string like this. Probably need to look at the string API. String API. Okay. From. There we go. Of course it is. Why does it? Why is it? Oh. Got to use let. This is what I was missing. Told you my Rust was rusty. There we go. Start a little bit better. I'm trying to work out why it's moaning at me here. Yeah. Uh, oh, okay. I'm just doing my method argument thing. I was thinking about a different programming language. Right. Yes. Okay. So placements. D1 and C1 and yeah. Okay, that's fine. I was thinking about adding another one. Let's just do it for completeness sake. J. That's our variant. That's what we want to get out of this. Right. So this is our expected placement. And we need our other list. Okay, let me think about it. Right, so yeah, okay. Yeah, right. Yeah, I'll move it. Let's call this all placements. And we're just going to create. It's probably too many. Don't worry about it. We can come back and jigger this around later to see what we've got. Right, fine. So 3, 4. Oh, what happened there? Oh, I missed that one. There we go. Right. Okay, so we've got all placements, we've got variant placements, and we've got an expected result. Okay. So all placements. Let's use this down here. And then we've got a variant. We don't know what our variant is yet. Honestly, it doesn't really matter. And we want a variant. Let variant and variant 1 seems reasonable. So we can create no, that wasn't what I wanted you to do. Okay, here we go. So now we've got this. Now we can create a function, which is going to be name, and it's going to give us self, and we're going to go self name. Okay, good. Magic. Look at this. Look at this. Oh, that's good. So we don't have a variant processor in order to get the results yet. So this is now where it's going to get more interesting. So I suppose we need and I am getting a little bit ahead of myself here, but I need to clarify some thoughts in order to work out sort of what I was doing in my head. You might have a quick discussion about what it is you're going to do, and then write the simplest test case first, which is an assembly variant processor, which processes an empty list of placements, or a variant with no placements on it. We can add these tests later, but they would probably be the simpler ones to do, rather than adding all of the placements and everything like that in to start with. But they'll be easy. They'll be very quick to add very shortly. So we're going to go assembly variant processor. And we're going to say it's a default one. No. Processing result. Yeah, sure. Now, I don't know what this is going to have in it. Probably nothing. Right, we're going to import it. And yeah, see, it's done this. This isn't quite right. This import default for is what we want to do here. Oh. It's always pub because it's an import. It needs to be. So that's fine. So we can make our assembly variant processor. Fantastic. So now we can create a method on an implementation to do something. Oh, now we're getting there. So placements and variant. Okay, well, thanks. I don't want to change the default visibility so it doesn't keep putting pub create on it. And this is going to give us a result. And this is going to be a result of a result of processing result. Oops, I've probably got this wrong. Oh yes. Yes, there we go. So when you return something, instead of returning, and this is one of the things with OpenPnP that I don't like about the code base, is that when you try and do an operation, and that operation fails for whatever reason, lots of the methods just return null. But in Rust, you use result objects, and a result object has a good and a bad, essentially, which is the value that you get, the type that you get back, or you get an error. And you can define your own error types. At the moment, we're just going to use the unit type for this thing here because we haven't yet defined how it might fail. Which in some situations is absolutely fine, but other times you want to have properly defined errors, such as variant not found, or I don't know, something like that. And Rust also has this question mark operator. So if you say let something equals call method have some arguments and then a question mark at the end, if the method you're writing that in also returns a result object, it will return an error result magically, automatically, as long as that error result can be casted or coerced, or I think that's the word, into the type that your enclosing method returns, shortcutting the rest of the method. So it's very nice for writing fail fast style code, where you check everything first and then you do your operation if everything that you need to do your operation is present. Such as, when we're doing this, we might want to check that the list of placements is not empty, for instance, which I suppose might be useful to do. So we've got this. We've got process. We can probably press run at this point. Oh no, we can't, because we haven't said it's a test. Now we can press run, look. So we can actually run some code. Look at this, it's amazing. The first bit of code on this project that we're running. Let's go. Right, well, don't have partial EQ, much compile errors, everything's totes fine. So you can't run assert EQ on something if your type doesn't implement partial EQ. So what are we trying to do? So on the processing result, and it very helpfully tells you what you need to do, which is exactly this. So partial EQ on processing result. Now, if we were to do this, I find it weird that you can't click here on this. Yeah, the usages thing. I might turn that usages thing off. No, on the struct. Struct. Right. Which is fine, but the problem now is that placement doesn't implement partial EQ. So that also needs to have it, and then that error goes away, which is fine. So now we can try running it again. But if this test fails, it's going to try and print out the differences between the two things, and it can't do that because it doesn't have the debug. So we're just going to derive debug for these things as well. Now, knowing what I know about Rust and deriving and all this kind of stuff, we're going to limit the scope of the derived until we know that we need them somewhere else. So what do I mean by that? When you derive functionality from partial EQ, it derives it for your test code and also for your production code. But there's overhead in doing that. It adds code to the resulting binary, and you might not necessarily want all that. Certainly in embedded programming, you definitely don't want that. So we're going to go config test derive thing. I think it's something like this. Oh, I forget. I need to look it up. Rust drive for test only. Yeah, someone on Reddit's done it. That's it. Config attribute. There we go. I knew it. That's what I want. Yeah. If you look at the source for the macros, I think I might need to install the standard library for Rust or something because it's not showing me the declaration for it. Then you'll find this details about what arguments you pass to the macro. Right, so we're going to do this, and we're going to do the same thing over here. And now we're going to try running it again. Use of moved value. Now the problem is that when we defined our vector, because this isn't Java, when we defined our vector, we said this vector has all these things, and now this vector owns these things. And then we tried to reuse the same placements down here, which obviously isn't going to work. So what are we going to do here? Do we copy them into it? Or should our vector contain references to placements? That's my first thought on this is that I don't want to go down the whole process of having something that manages all my placements. It might be that we should be having a vector of boxed placements. Let's look at box again for a moment. Rust box. So box is how you allocate memory and stick things into it. Yes. Yes, I knew this project was going to be interesting when I start using standard library stuff more. Because most of the things that I've been doing over the last couple of years have been all static allocation and so on. So not much in the way of boxes, basically. Okay, well let's just try a couple of different ways, different approaches to do it. Let's say my vector is okay. Let's do this. Let's do that. So now we've got a vector of box placements, right? Yeah. Right. So our processing result now wants something else instead. I'm just going to go with change type. So what that will have done, it will have changed these. Yeah. Yep. Processing result. Right. Let's see where we get now. So we still can't use it. Because we moved the box. Okay. Let's yeah, I'm gonna undo this. Oops, yeah, I don't like it. Yeah, we're just going to use references in the list. I think we're going to use references in it. I'm not sure. Let's name the lifetime. See where we get to. Yeah. Any lifetimes everywhere, everything's fine. Right. Yeah. Okay. It seems reasonable that it doesn't own it. Right, amazing. Fantastic. Look at that. We can actually run code. Dun, 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 and it panics. Of course it panics. And the reason it panics is because whatever said not yet implemented. Probably could rename this a bit better. Let's go. No, I'm doing it afterwards. Right. So the reason it's failing is because we haven't implemented anything yet. Let's go error. Right. Oh, press the wrong button. Right. And it'll now fail because it returns an error. Let's make a passing test to make ourselves feel a little bit happy before we delve into the implementation of this a bit. So let's say fun no basements. Yeah. What am I doing wrong here? Right. Let's. It'll probably clear itself up. in a minute. Okay. Add format string. Oh, it's because it's supposed to be as for EQ. Okay. Right. All placements. Right. Let's say no placements. And we're gonna say, I suppose we can just do vec with an empty list, right? Variant. We need a variant. Yeah. We'll steal this one. Here we go. Okay. Do. Oh, I didn't run all the tests. Let's do that again. Oh, enough. Okay. All right. Here we go. Okay. I don't really care about the panicking right now. We get to use run. But why? Oh, do I have a filter? Yes. Okay, fine. Right. So no placements for works. Amazing. Because we're returning an error. Seems reasonable. So I suppose placements dot size length. Right. Let me say go. Yeah, look, we've our first bit of logic. Amazing. This is so stupid, it's hilarious. Programming. Right, so what we're trying to do is get some of these out of here. But we haven't got a way of doing that yet because our variant doesn't have a way of extracting the placements from the list. So it feels like we need to add a list of ref deses. Variant ref des. I don't like ref deses like that. Ref des list. Seems reasonable. I suppose this is going to be a vector of strings. We're going to say R1. An equals would be helpful, wouldn't it? And a semicolon. Oh, it's not new, it's from. For some reason, I've got this irking, nagging feeling that there's a different way of creating strings. How I'm doing it. But it'll be easy to do a search and replace later, so everything's fine. D1, C1, and J1. So fantastic. Our variant can now contain this. Everything's fine. Right. But we don't have the argument here. So we're going to add it. Now we go back and have a look, and we've got our refdes variant list added. And again, this is why I'm really liking Rust Rover and IntelliJ IDEs, because I don't have to type out all of this. I can think about what I'm doing and have the IDE do some of the boilerplate stuff for me, and it helps you even remember the syntax of the language, which is very helpful if you switch between a few different languages, which I do. So yes. So now we need to add that to our structure. There we go. So now we've got a way of doing this, but we've broken our other test because it doesn't have anything in the list. Okay, good. Right. So now we've got some pieces of the puzzle, and we can write some code. So I suppose we want to go placements dot. We want to use some sort of like filtering thing, really. Yeah. Got to remember my Rust syntax now. Okay, let's look at the look at this for a moment. So basically, the thing returns true. If it returns true, then you get the thing back. Oh yeah, a Rust syntax coming back to me. So we've got our thing, which is going to be a placement, and we're going to say placement dot refdes, and we want to see if it's in the list. So we've got to iterate over two lists. But there's a way of doing this in Rust where you iterate over two lists, which is zipping. Let's park that. Placements dot zip iter.zip, and then you have to go variant refdes list. And I think we still want to do filter. And we're going to go A, comma B. I think, yeah, so the refdes list is a list of strings, which is refdes is. And the first thing in it is comes from the placement. So this will be placement. And this will be refdes. And we're going to go, oops. And we're going to go, we've got to make it return something. So if you wanted everything back, we would just return true here, I think. And we need to use the result object. Right, and then it stops moaning at us. We're going to use that in a bit. But now we need to do some logic, which is placement dot refdes eq, probably refdes. Now we're going to get situations where the refdes is in the wrong case and all this kind of stuff. We can deal with that. Everything's fine. And then we're just going to say OK with a processing result which contains foo. And this is going to be foo. But at the moment it's called that. Now you have to go. You have to call collect on the end of it, don't you? And then you get the vector of things back. Right. I remember all this. What's foo? What's foo called? What's foo? This is placements, really, isn't it? Yeah, variant placements. Okay, fine. We don't need this anymore, and we just return it. Okay. Takes 2 arguments. Does it? What am I missing here? Takes 2. Wait, what? 2 arguments? Why? What am I missing? Filter. First argument, second argument, right? But did I do the wrong? I might need to look up how to use zip. Because apparently. Oh, wait, hold on. Where dot iter? No, I need to look up how to do zip. See, the Rust API is pretty nice. Let's go to the top. So we've got 2 things, and you get the iterator of each of the things, which is what I was doing. Then you say, and then you basically get an iterator, and each one of these iterators then has 2 things in it. What am I missing here? Was I doing it right to start with? Let me just put the type on there. Argument. But trying to remember. Okay, let me assign this to something, and we can see. So the type of this is zip iter placement iter string. Am I doing this right? Yeah. I'm struggling a little bit here. Brain not down with the API yet. Oh, okay, yes. Live stream chat. I didn't realize anybody was chatting in the chat thing. Let's have a look. Looks like you have unlimited spare time. Wrong account again. Hearing code brings back a lot of memories. Thanks, Quick Flash. Yes, using Chat GPT. Yeah, probably could do that actually. There is this thing here. I haven't played with it yet. I might have a look at that at some point. I feel I shouldn't need to reference or use that thing right now, but maybe I'm looking at it wrong. Maybe it would just save time if I did. Yeah. Why am I? What am I doing? Let's just go P. And predicate is a function which takes a reference to an item. The item is from the iterator. Right. Let me just comment this out for a moment. And just build that. Right, must be in at this point. It gives me a tuple struct. Right now I can see the type more clearly. But I could have sworn that. Let me just take this iter off here 1 second. Yeah, okay. Take it into iter string, yeah. Right. Okay. Yes. Right. Now I remember what I'm doing wrong now. So reference placement. Reference to string. It's something like this because this I want to structure this. Okay, let me just I thought you could do it here. Let's call it Z. Struggling to remember all this stuff. Oh, I've got to look it up. Assignment or something. Good lord, destructuring. This is it. Destructuring tuples. Yeah. That isn't quite what I was after. Yeah, this is it. Not really matching. I want to create local variables with the name of each of the things in them. But I'm failing to remember how to do it. This is... Oh, good lord. Oh man, it's been a while since I've done this. Could have sworn I had this right. Why is... Why can't I remember how to do it, and why can't I find the example? It's an assignment. Destructuring assignment. Oh, Rust. Yeah. This is what I want. No? Struct, and then we say... But do you... This. Is this right? But I'm also struggling to work out how to get the things out of the zip thing. Let me look at this zip thing again. Right, so right, okay. Yes. Okay, because I forgot that zip gives you it gives you options. You either get some... Oh, wait, no. The iter gives you the option. I don't think this is what I want to do anyway, to be honest, now that I'm looking at it. Yeah. Yeah, I don't want to zip them because it doesn't go over all of the items in it anyway. So let's just forget about doing that. That was wrong. It's not this. Yeah, okay, fine. Let's start again. We know we want this though. Yeah. Okay, let's just do it the naive way to start with, just so that progress things, then we can come back to this and improve the implementation at some point in future to make it less rubbish. Okay, we're gonna... We're definitely going to iterate over the list of placements. Let's just make sure that this works. Oh, and then go dot collect. Let's just make sure that this builds first. Um, and then we'll come to the implementation of line 50 when we get to it. A lot of references. Yeah, struggling to remember any of this. Well, this isn't going as well as I thought it was going to today. And like I said, I'm totally rusty on this. Why? That's a long error message. Am I using the wrong thing here? There's a magic, yeah. It knows the type that we're trying to create because it infers it from the processing result. But let's just specify it explicitly here because this is what we're trying to do. Yeah, don't need that. Do we need to clone the iterator? That's yeah. cloning on the vector. Let me think about that. This isn't the right way of doing this. Yeah, lifetime. Fine. The result is. Oh dear, this is where it starts getting funky. See, Java, everything's by reference, and some of this stuff is easier in Java and other languages like that, but here we are in Rustland. So the not sure if this is right at all. And to be honest, I'm not sure I want to be using lifetimes and so on in the processing result. It feels like I should, because I don't want to copy them all. Definitely want references to them. The lifetime of this, but the thing that we're returning has different light. Okay, yeah. Lifetime too. Yeah, the right lifetime. This. Let me look at this processing because we added a lifetime processing result, which is the lifetime with placements. I think maybe this. Yes. There we go. So the result object, the lifetime of the things in it are the same as the lifetimes of the placements that was in it there. Right. Okay. Phew. Let's run it. Whatever, it fails. This is good. Okay, we're iterating over things. Right, so now we need to fix this. Okay, progress. Progress. Right, progress. Right, I'm going to take pause for a moment while I go and get a coffee. Because coffee required. Okay. All right, back in a jiffy. Okay, okay. All righty then. Got my favourite mug. Here we go. It's my Wally mug. I'm not sure if Kevin's still in the chat, but I don't have any biscuits. He'll laugh. Not the American biscuits, though. Yeah. Biscuits. Good lord. Run out of biscuits. It's no good. There was just crumbs in the box. All right. So we've got to return true or false somehow. So the variant has a bunch of strings. So let's go variant dot variant contains. Sure. Let's just do this. Placement dot refdes. Sure. Except no. Huh. Okay. I mean, that's good. So what have we got now? Got our expected result. Is our expectation correct? R1, D1, C1, J1. R1, D1, C1, J1. Okay. And what we got was R1, D1, C1, J1. Okay, I need to switch these round. I believe. No, I was right the first time. Damn it. Just misreading it, I think. Wait, what? Wait, what? Wait, what? Variant placements. Oh. I've got the wrong things here. So R1, D1, C1, J1. So this is 1, 4, 7, and 8. Oh, our expectation was wrong. Okay. It might be helpful if they had better names instead of 1, 4, 7, and 8, really. Might make it clearer. Oh my god, we've got a passing test. Great. Let me just take this one off here for a moment, for a second. Oh, don't do that. Oh, just comment out. Is it Control Shift? Yes. Okay. Just want to make sure I've got the left versus right thing correct. Yeah, it really only shows you left versus right. It's different to other things. It's fine either way. So I want to say that the result is the expected result, which is why I've got these this way round. But in some other frameworks, the expected results goes first, but in here you just says left versus right rather than actual and expected like you get in some other test frameworks. So I was just trying to remember that. So it's fine. Great. Okay, we can undo this. And magically we can create our list of placements from the list. Fantastic. So, okay. What's next? Yeah. No placement. Yeah, well. Because there's two lists of things, is what I'm thinking. There's one where you've got no components, no placements defined, and the other one is where the variant has nothing in its refdes list. What I want is a sort of parameterized test at this point, which is where you define the contents of both of the vectors from two separate lists, and then if they're both empty, it should fail. If one of them's got stuff in it, the other one doesn't, it should immediately fail, and so on. But I'm not going to do that just right now. I'm not going to go into the parameterized test stuff. I don't want to have to remember that today. No placement. Empty variant refdes list. But that means we need something in here. I mean, the test will pass as it is at the moment, which is a little bit odd. But it passes for the wrong reason, because the error is because of this being empty. So we need to put something in here. So we'll just define a placement. Yeah, right. And now it doesn't pass because you just get an empty list back, which might be okay, but we said we want an error. We can come back to that, but it's fairly simple. I'm just going to see if there's another. Yeah, there's an is empty on these things. Okay, so now everything should be fine, right? Yeah. Okay. I think we should do our first commit. Sure. Why not? Git. Did I even create a Git? I don't remember doing it. Okay, well, maybe we've got one. Many unversion things. Okay, I want to see the directories that the things are in. Some point we're going to have to talk about licensing. Licensing. You can get a license file to it. Good lord, I've not even done any of this stuff yet. It's going to be GPL, just if you're wondering. But I haven't done it yet. So we're going to add some cargo files. Let's have a look what we're committing. Seems fine. We can probably bump this Rust revision. What is the latest? Who knows what the latest Rust revision is? Rust edition. Oh look, not yet been released, and this one has. What are editions? Okay, so 2021 is the latest one, so that's fine. And we've got no dependencies. Okay, so initial commit. That's all fine. Okay, let's add some dip trace files that we added. Yeah. Okay. We've got this main file. We don't really want this. Let's just replace this with to do for now, and then commit that with all this. Before we commit it, though, we need to fix the name of this. Whatever. I mean, what's it doing? Now's a good time to look. It takes a list of placements and a variant with a list of ref deses and spits out a result. So what is it doing? It's not really a find. I mean, we called it process. I don't really want to call a test process, even though it is testing the process method, which probably needs to be named better anyway. And we've got this processing result. I don't really like the name of that. Anyway, red green refactor is what we're trying to remember. Whatever. Let's just call it process for now. We'll just call it process. Right. And then we go first cut of assembly processor, assembly variant processor. Okay. Everything's totally fine. We don't want the IDEA files. It's fine. Right. Yay, we've got a commit. Magic. Let's push this up to a repo. This seems pretty reasonable at this point. So for that, we're going to need a terminal. Okay. Right, so terminal-wise, I'm on Windows, but I'm using MSys2 as my terminal. Don't like command prompt. Don't like PowerShell. PowerShell just, it confuses me. I don't get on with that at all. It's weird. So we're just going to go sort of like Linuxy kind of thing, you know, which is very similar to, which is going to be more similar for everyone else running it on all different types of hardware that they could be running this on. You know, Mac OS and Linux and all this kind of stuff, right? So fine. I'm not using WSL. I'm not using WSL because you can't do various things with it with regards to running Linux binaries from your IDE. Whereas if you've got MSys2, the binaries that are in it are UCRT64 binaries, not ELF files, and you can run those from within your IDE. So that's why. Plus, also, don't want to maintain a Linux thing on my machine. You know, maintaining MSys2, not quite as evil. Still, there we are. Right. Anyway, So we put some sort in here. Yay, good. We'll have a quick log of that. Yeah, everything's fine. So I created a repo for this somewhere. I've got to find the thing. Yeah, here we go. github.com/MakerPnP. Now, I created some repos here. I created operator, planner, and call, but I think that was a little bit premature. So I'm going to delete these. Settings. I think. Do you know what? I'll tidy these up later. I won't bore you guys with this malarkey. So we're just going to create a new one called MakerPnP. Fine. And it's going to be a public repo. Let's say GPL free. But if I do that, it's going to create a file there. So I'm just going to say none for now. Right, great. We've got all that. Everything's fine. Git remote origin clunk. Good. Git push origin master. Sure. Yay, first commit. Pushed for the world to see. Right, we're on. We're on. Okay, cool. Okay, probably should do a README and all this kind of stuff and add license files and everything. Not yet. We'll get to all that. So let's refocus on what we're trying to do. What's next? What's next? Honestly, the amount of time this is going to take is just ridiculous. Right. But, you know, once we start getting into it, everything will be fine. So let's think about what we're trying to do for a minute. We were trying to go, let's bring up the CSV file for a moment here. So we're trying to say that if you're trying to create an assembly variant, which is based on these list of refdeses, and it may be that we want to define our variant in different ways, rather than, you know, like an exclusion list rather than an inclusion list. But we can deal with that later. What we say is that give me the list of placements for this assembly variant, which we've now got. The next thing we need to do is somehow go from our stock of components that we've got in and work out which things are compatible with the placements in the PNP file. Now, what we need to look at is a manufacturer's or a supplier's website in order to be able to make some reasonable decisions on what we can do for this. So let's go back to LCSC again. So if I'm placing an order for these resistors, let's say I want 10,000 of these. Right, they're in my cart. Fantastic. And let's say I needed more, and they didn't have enough of my favorite ones, so I'm now buying the next most cheap one. Let's just say this hypothetical scenario. Right, so we've got two things. This is how you see things in supplier land. You've got a supplier part number, you've got a manufacturer's number, and you've got a manufacturer. This is common across all suppliers. Let's have a look at another supplier. So we're going to go 04, 02, 300. Thanks, Mouser. 04, 02, 330 ohm. Go. Come on, Mouser. Right. What do we got? Inductor. No. Okay, great. Look, we've got some parts. Let's order it by cheap. Order by cheap. In stock, I suppose. Apply. Here we go. Right, we've got a part. Let's just add 1,000 of these and 1,000 of these to the cart, and we'll have a quick look at the cart. Continue, yada yada yada. Continue, great, fantastic. 2. Okay, show me the cart, you basket. Okay, fine. You know, we'll have 10,000 of each. I don't really care. Fine. Right. So going back to the commonalities is what we're interested in. Again, we see the commonalities immediately. We've got the supplier part number, the manufacturer part number, and the manufacturer. So let's define the idea of a part based on 2 of these 3 things: the manufacturer and the manufacturer's part number. Right, let's go back to the code. Not hello world, MakerPnP, here we go. Right. So, we're going to rearrange all of these things somewhere at some point. So let's, let's create a new file called part. Is part the right word, or should it be component? I tell you what we're going to do. I'm going to say part for now. What we're going to do is go back to inventory, which is what I plan to do integration with, right? And we'll see what inventory calls these things that it can make that you can have, right? So we're going to open the demo and all access, no limits. Let's go. Right. Yeah, sure, we can save that. So here it has parts. So they not component. Granted, you have electronic components, it's fine, but inventory calls them parts. Let's just have a look at some resistors. They might even have some in here. There isn't one. So let's just see how you create one in this. So parts, right? There's already some created. It's fine. Let's just try creating a new part in here just for a moment. So at some point, there'll be some integration between what you buy from a supplier and the data that is in inventory. There's already existing tools that allow you to import your order history and also import the parts from the supplier into inventory. This stuff already exists. It's like Python scripts and things like this to do it. I gave it a little whirl once. It didn't seem entirely hideous. So we're going to go back to Mouser and we're going to go manufacturer part number. Name, variant, here we go. Supplier. Look, it's already got these things in here, and it's ooh, that was the wrong one. That was this one. Mouser calls it one of these. The manufacturer was Royal Ohm. Oh, you see, you can't just paste it in. You've got to create the manufacturers first. And see, this is why this is a bit of a faff. There's quite a lot of setup for this. But, you know, you choose your parts, and only once you've chosen your parts can you create an assembly variant anyway, you know. There is some overhead in doing all this, but yeah. Okay, well, it doesn't exist. So I suppose what we're going to have to do is open up a new window. Am I doing the right thing here? See, I'm not very good at navigating my way around this. I'm going parts, and it takes me to here. How do I do manufacturers? Subcategories? No, not really. Parameters? Part parameters? Not really. By manufacturers. Here we go. Right. We're going to go new manufacturer, and it's going to be called Royal. Oh. Don't care. Submit. Okay, fine. Right, so now we can go back to here and go. Can we go Royal Home now? We can. Fantastic. Brilliant. Manufacturer part number. Back to Mouser. Manufacturer part number. Great. And then we're going to go back to Mouser, and we're going to say this is the description. And we're going to use that here. Here. It's a bit rubbish though, isn't it, that name? Well. 0402 30 ohm. Quarter watt. 16th watt. 0.01% tolerance. I mean, honestly, this is probably better here than here. It's not really going to matter right now anyway. We don't really care too much. Right. So this is how you can define a part in inventory. And then when you buy it, you create a purchase order with your supplier, and you give it the list of things that you want. And you can import purchase orders into inventory using either downloading the data off the supplier's website, or doing what I was doing before. You can use their APIs to do it, or you can download the data from your purchase order history and then import into a CSV, and then import that using some scripts or whatever. Right. So, and this process is the same, you know, using LCSC or using Mouser or DigiKey. There's basically supply part number, manufacturer part number, and manufacturer. Things like description and stuff like that aren't important for the pick and place machine. They're only important for the operator if they're fiddling around with the machine and it says R1's run out. You're like, well, what the bloody hell's R1? You have to go and look it up. So sometimes it's useful to have that information available on the machine display. Right, so part is what we've decided. We're going to call it. We're going to give it a struct, and we're going to say it's going to have a string, and it's going to be manufacturer part number. And it's going to be called part. Right. Right. Now, for the purposes of picking and placing, you don't need to define a manufacturer as like a separate object, like a separate structure. It's fine just to have the string of the name of the manufacturer. So we're going to do that to start with. We can always come back and change our mind if we want to. Oh, not semicolon, it's comma. Rust, isn't it? Oh, look at this, comma. You Java and C people will be like, oh! Moving on. More coffee. So that's what we want. Fantastic. Now let's look at what we're trying to do again. So I could purchase or have purchased, like some different resistors, different suppliers. So my assembly variant could be built with either resistor A or resistor B. So somehow we need to say that if you see a 330 ohm Res 0402, then these things are suitable. So there's essentially a mapping. There we go. So we're going to call it part mapping underscores. I don't remember. Part mapping. Fine. So main. We've got some stuff. This I'm not sure about these things. I might get rid of these. Part mapping. What the hell's a part mapping? It's a structure. But what does it have in it? It probably has a part reference, right? And it probably has some criteria. Because you've got to find it, right? So in order to map one thing to the other, criteria. Now there's a couple of ways that you could do this. You can have an exact string match, fine. You could have regular expressions, fine. You could have starts with, fine. It's another form of regular expression or whatever like this. But they're all forms of criteria, basically. You go, does this match? So you need to define your criteria somehow. So I think what we're going to do, and this is probably wrong, but my thought is a vector of criteria. Let's say, and this is very, very specific, this is, so this is going to be part mapping criteria. Sure. I'm going to put this in here for now. Right? We don't know how we're going to define this part mapping criteria thing. And we've got to deal with lifetimes already. So go to part. And we've got criteria. And the criteria will probably have a different lifetime than the part. So you can imagine that the criteria might be like live for the length of the user interface or command line tool that we're using to do whatever it is that we're doing. And the parts are probably loaded in from like a CSV file, right? Oh, why did I do that? That was silly. Here we go. Why is it complaining? Yeah. I suppose. It's got to live at least as long as it. The string's got to give live longer than the. Oh, what's this? It's imported the wrong thing. it's not public. That's why I didn't find it. Yes, yes, please. Right. Everything's fine. Everything's absolutely fine. I honestly, I don't know whether we do need this thing or not. Okay. So the next thing we're going to need, and look at this, I've written production code before I wrote a test, but I think it's fairly important this bit was. We're going to say more tests. Oh no, I've done it wrong. Config test, here we go. Then we're going to say, I want a test. And it's going to be something like find or match or something like this. Match, you know, you could just call it whatever again and then come back to it later. But I want to think about this a little bit. I want to match match parts, I suppose. So when we use our part matcher to match, and we're just going to do a single part for now. Match is probably a reserved word, so let's call it process. I don't care. We're gonna go maybe. I don't know, process. It's a process. I'm using the word process. We're gonna say we definitely want a part, and we want some part mappings, because but we don't start with a part, we get a part. Right. Right, so we process part mappings, but in order to process part mappings, we're going to need a list of things that we've purchased, which are parts, right? Okay, so when we do that, then we expect something. Assert part expected part, sure. Everything's going to be fine. So we're going to say given. And let's start with this. And we need to create a part. And we decided that a part was comprised of a manufacturer part number and a manufacturer. I'm going to reorder these. Because you go to a manufacturer and ask them for a part. And we're going to say MFR1 part 1 seems reasonable. But we need to import this, and everything's fine. And we need to create a method, which is fine. And we get, oops, and this is going to be manufacturing. And then this one is going to be NPN. And it's going to return one of itself. And we go, right, so we go self, because we said we're going to return one of those. And we're going to give it the manufacturer, and we're going to give it a part number. And we're going to put another comma. But here I said stu, but it's not right. I just have this feeling that there's Yeah, that was it. I knew there was a. I knew it. I need to go back to my other tests and use toString instead of whatever. I don't know whether this is more efficient doing it this way, but it's only test code, so I'm not going to worry about it too much. Probably look it up at some point. Okay, so we got a part match here. We got an expected part. Great. Right. So clearly, this expected part needs to also be in the list of parts. Right. So let's say, right, but the thing is, I said part is going to be one of these, but really, let's say reference to part 1 and go let part 1 is this. And then we'll create another one and go part 2 and 3. It seems reasonable. Oh, honestly, it doesn't really matter. Right, fine. Everything's fine. So we got part, and then we got go part, and it's going to be a vector of part 1, part 2, and part 3. But we're going to have this whole moving problem again, so we're going to create references to the parts probably in here. Seems reasonable so far. Now part mappings. Oh, part mappings. We need some part mappings. How do we create part mappings? Oh, this is going to be more interesting. Okay. I don't know yet. Let's just say it's going to be a vector of part mapping 1, 2, and 3. Sure. Part mapping. Move this down a bit. And. Okay. So we need some part mappings. So let part mapping 1 equals. How do we create a part mapping? Okay. The tricky bit is going to be creating the criteria. Part mapping. New. Does it need a name? Does it need, what does it need? It needs a reference to a part, which is going to be this, and it's going to need a vector of some references. Well, is it going to, I don't know. Is it going to be a reference? Don't know. See, it might have been premature thinking about the reference, because what else is going to own? Going to need this part mapping criteria thing. Good. I think it's just going to own it. Let's make it own it. And if it doesn't own it, we'll come back to it. Criteria 1, sure. Part 1, criteria 1. Fine. So we can go let criteria 1 equals. And now we've got no idea what we're going to do. Right, interfaces, implementations, and traits, and all the rest of it is what's coming into my head right now. Because the part mapping criteria, it's not really. You just need implementations, really. You need an interface. But Rust is a bit funny with its interfaces. Let's just go back to it and go interfaces in Rust. You have traits. traits are Rust sol notation interface. It's fine. Yeah. Okay, so let's have a quick look at an example of one. Traits are interfaces. So, trait. Let's go back. Part mapping criteria. We defined it as a struct, but I don't think this is true. I think it's a trait. Right. Now, you get an error. So, dynamic traits and all this stuff, don't know. We're just going to go with what it suggests to start with and then go back to it. So what we're going to say is that we're going to say we want an exact match criteria because it's the simplest thing to do. Right, and it's going to exact match on the manufacturer's name and the manufacturer's part number. Right. Yeah. But this is going to be a structure, and it's going to have the exact same fields and implementation as the part. Right? I'm just going to steal this. And we're just going to delete that, paste that in there, paste that in there, and yay, we've got a criteria. Okay, fine. We're going to import this. Oh, yeah, of course. To string. Fine. So we create criteria. Great. We can duplicate this a little bit. There we go. Oh yeah. What happened there? Stop that. I pressed the wrong button. 2, 3. Oh, you gotta love this IDE's multiple cursor support. It's fantastic for doing things like that. Righto. Right, so we've got our part mappings, we've got our part criteria, but we don't have a part match and we don't have a process method yet. So I suppose we need to create one. And let part matcher part. Do we need a new one? Or should we just call an associated method? Okay, we're just going to call an associated method on this. And then if it turns out not to be the case, then fine, so be it. Right. Struct, because you need a struct to create a method, well, or an enum, or something else like that. Fine. Right. So now we can import it, fine. And now we can create an associated function, which is great. But it put it at the top. I don't want it there. Oh. I actually do sort of want it there. Let's just relocate that. Okay, right. Great. Let's see what happens if we try and run this now, because it might compile. No. Right. You can't create part mappings because it doesn't have a size known at compile time, which is fine. Things that have a size known at compile time have a reference, because a reference has a size. A reference to something has a size of a pointer, which is fine. I'm just going to take this off and see what it suggests to me as other things. Because you can have zero-sized types, right? Not sure what to do at this point. Let's just say No, they are going to have a size. And these, yeah, they are. Yeah, it's going to be fine. Fine. Right, we'll do that. Type annotations needed. Yes. Yes. We didn't do that, did we? Parts and part mapping. Okay. Parts. No. And part mappings. And this is going to be, I don't know. Criteria. Well, no. Mappings. Are they? What are they? What are these things? Yeah. Oh, what happened there? But the part mapping has got 2 lifetimes, which need to live. Both of these things need to live at least as long as the reference to the thing that is owning them. So we're just going to reuse mappings and mappings, I suppose. And we're going to say that the lifetime of this is mappings. It probably makes sense. I'm going to rename this lifetime to mapping. Yeah. Even though there's multiple ones of them. Right, we also need to define the return value of this. It's being a reference to a part. But the parts need to have the same lifetime as the parts that are passed to them in the parts argument, which therefore needs to be defined as parts here. Right. Parts with a plural. Mappings, parts. Because the lifetime is used here without the plural, and it's used here sort of with the plural. Don't know. Don't care. Right. Okay. No part mapping can be created, right, because we probably haven't made it yet. Yeah. Okay, we didn't make it. So what does it do? Part mapping. It takes a reference to a part and a list of criteria. Part. Sure. And criteria. It's not that. This is going to be a reference in to part mapping criteria because we want to use the interface here, right? Which means down here, this probably needs to have an ampersand in front of it. Probably. And this is just going to be, oh, I'm not sure what happened there. Okay. And I'm also not sure what happened there. Fine. And it's going to create a self, and it's going to return a self with part and criteria in it, no? Criteria. Plural. Fine. Okay, now what happens? Criteria not right, because we haven't implemented part mapping criteria on exact match criteria. So this is going to be easy. Import part mapping criteria for exact match criteria. Now, at some point, there's going to be a method in the trait, and it's going to be fine. But not yet. what's there? Mismatch types, part mappings, probably because it's vector of the. Yes, we need references up here. Bit hard to type on a split keyboard with one hand. All right, what have we got? Probably binary operation cannot be applied to this yet because of the derived malarkey. So we'll go back to our assembly thing that we had earlier where we defined partial EQ and debug. And we'll go back to the error message, and it was bitching about part here. So in order to be able to compare it for tests, we need to do that. Fine. Let me give it a go. Explicit lifetime required part. Yeah, we know. We need to use the lifetimes that we've defined here and and our part mapping criteria doesn't have any lifetimes. Fine. Okay, good. It compiles. Look at that. Amazing. Let's run it. It should fail. Not yet implemented. Great. So, right. Process. So, in order to see if we can extract or find a part from the part mappings, we need to iterate over the parts and apply each part mapping to it to see if it matches. So let's just say let result equal, and then actually no, let's not. Now you see here we're saying this is wrong. This is wrong. Look, let me go back down here. So when we process this, it might be the case where we don't find a part. So we're going to say it's some part. But the problem is this ain't right now. It's option of a reference to a part. That's what we want to do. And if we say none here, it doesn't match. Perfect. But it runs, which is good. So let's go part mappings dot iter dot. Oh well. Okay, the problem now is that potentially multiple part mappings could be applied. And because it's entirely possible to create multiple part mappings that are identical. It might be silly to do it, but if you said 0402 resistor matched this part, and you just said 330 ohm resistor matched this part, then you have to somehow choose which part you want to use. And so, okay, let's think about it a bit more then. Go back down here. One part, multiple part. Right, part matcher. Now, because the problem is, and I've run into this before with the other software that I was creating before, is there might be multiple parts that you could use for your variant that you might have in stock. And you would need to say, I want to use this part, not this part. and there has to be some sort of selection process so that you know which part that you could use that you have. You have to know which part you're going to use for this assembly variant when you load the pick and paste machine. So the part matcher needs to be able to return all the match parts. So let's say expected parts is going to be a vector which contains one part. And if it didn't match any, I think it's probably better to return none rather than an empty vector. My thoughts on that will probably be clear when we start to put all these things together. At some point we're going to have to start putting these things together, but it's not right now. Right. So it's going to be an optional list vector of parts. I wish it wouldn't put the second one of those in when you do that. I might have to turn that off. Does it still run? Yeah. Oh, because expected parts with the plural. Okay, it runs too. Fantastic. Righto. So now we can go back to this. Now we can iterate over the thing. And again, it's just going to be another one of these simple sort of like filtering things, right? I think. Part mappings dot filter. No, iter dot filter and map. Because we want to change the result because we don't want the part mapping back. Maybe we do. I'll tell you why I think we do. If you've got imagine you've got a user interface or a command line tool which iterates over all the parts and it finds some parts that match, but you don't know why as the operator or the user that it's come back with multiple things. Interesting. Okay, hold on a second. Each part mapping only goes to one part, right? So if we returned the part mappings that matched, the consumer of the result object can extract the part from it themselves. So instead of having an option of vector parts, we have an option of vector part mappings. That way, we could display to the user that ran this which part mappings we use to find the parts. And I've needed this before, so I'm going to go with that. Part mappings. That's interesting. So it's mapping. Oh, part mapping. Yeah, I mean, so the lifetime of that needs to be that. I might be confuzzling myself right now. Oh, good lord. Expect part. Mappings. That's what we want back. We want to say that this one matched this one, and this one matched this one, and this one matched that one. So expected part mappings. So this is actually going to be a bigger list than this. We're going to get each one back. Am I going mad right now? Am I going mad? I might be going mad. And then, oh, wait, my brain hurts. Uh, okay, my brain hurts now. What am I trying to do? Um, oh dear. Definitely component, Commander Guy says. That's interesting. I hope you like my reason not to use component. The component's this funny term. Yeah. Part or element of larger of a whole. See, it sort of is and it sort of isn't. A part. It's yeah. Go back to right. Yeah, I'm getting confused now. Okay, I'm going to run with this, and then we'll come back to it. And once we add some more tests, hopefully it'll be probably clearer to me and everybody else. So we're going to iterate over the part mappings. Are we going to iterate over? No, we iterate over the parts to find the mappings that match the parts. Right. Iterate over the parts. And this is why I'm getting myself confused. Then we're going to filter. We're just going to run this just to make sure that everything's fine, which is not. Missing lifetime specifies why, where. Part mapping needs part and criteria. So lifetimes. Good lord. Okay, foo is going to be whatever this is. Vector part mapping, vector of mapping thing. It's going to be this. Got one too many. There we go. Right, that should shut it up. Part mapping. A reference to a reference to a reference to a part. That's a lot of references. I'm not entirely sure that is what we want here, but we did this before and it was fine. I need to know more about what this is doing. Right, but we're iterating over parts. So what we've got to do is filter map. Right, but instead of returning this, we go let's just say part mappings dot. We'll just do this for now. Because filter map, you're supposed to return You're supposed to return the thing that you want to map to. Yeah, so you can do the filter and then you can map it, or you can do it all in one go. Okay, go back to this again. Brain hurts. The implementation is always the tricky bit. All the tests and what you want to do, that's easier. That's what I find. So I find when I get in this situation, introducing a temporary local variable and then looking at the type that comes back be useful on this. Yeah, but it doesn't know what that is. That wasn't helpful. Parts is this. Iterator item is reference to a part. Yeah. And then it's saying, oh, wait, no. What does this go? Let foo equals foo. Let's say bar. Oh, this is because when you do get, it might not be in the list. So let's just temporarily just go unwrap on this just to get that out of it. And then a reference to part mapping. So we wanted a reference to a. We wanted a reference to it. Why? Oh, yeah. Oh, and filter map needs to return some if it matches. Yes. Okay. Okay. Value of type part mapping with 2 lifetimes cannot be built from an iterator over elements of. Because this needs to be a vector. Because you get a list back, right? Okay. Right. Yeah, okay, so because we were comparing parts and so on, and now we're doing part mappings, we need to do the derived bit on the part mapping. And this is gonna be more interesting because how can you possibly derive debug from a criteria, which is a trait? Um, so uh, can you put a derive? I forget entirely. Um, I mean, not entirely sure. Part mapping criteria. It just means that everything's going to need this. Um, yeah, that's what I thought. Uh, how do you say that your trait needs to have an implementation? Um, um, ah, I've totally forgotten all this. Okay. I mean, uh, hmm, yeah, I forget this. I forget this. Let's go Rust. Um, derive. Require. I don't know. Require. Yeah, trait bounds, isn't it? Let me just look up this. Yeah. Must implement the. Yeah, that's right. So we need to specify trait bounds, really. I think. So if we say instead of part mapping criteria here, we're just going to see PMC. And we're going to try and specify a trait bound for the thing, which is done by saying PMC. And then I think you can, there's two forms you can do. You can do where PMC is part of mapping criteria plus debug plus partial EQ. Is that right? The thing is, we only want this debug in the partial EQ for test purposes. Um, trait bounds. Okay, so what we're going to say is trait PMC. Is it alias? How do you do it? Alias in Rust? I can't remember. Rust type alias. Okay, you say type alias is this, is this. Uh, type PMC. Oops. Hold on. Oh, that's wrong. Oh, type aliases. And then you say what it is. We want it to be this, right? Do you? Plus debugging. Is this how you do it? Auto traits can be added to it. I want to define a type which has got these things in when you've got this on it, and when you don't, you do the other thing. Done this before, but I don't remember. Forget the syntax for this. Type whatever type param bounds is that where I want to be specifying them? Is that right? No. I must be misreading this. It says type and then an identifier. And then optionally generic parameters, followed by colon, followed by type param bounds. And type param bounds is made up of a type param bound and a plus and a type param bound, potentially repeated many times. Okay. Well, I need to see a better example. Rust trait type alias with bounds. Trait bound and type alias. Yeah, maybe I'm thinking about this wrong. Okay, look, I'm going to come back to that for the sake of moving on. We're just going to derive it all the time. But we can come back to it. We can say fix me only want debug and partial EQ for test. Okay, fine. Moving on. Come back to that. Missing type arguments. Oh, no, don't want that. What? What's going on here? Oh, I need to take this out. No. Okay. I'm probably getting this wrong. I don't want to specify a part mapping of a particular type. How do we say I want? I can't remember how you specify trait bounds. I can't remember how I specify trait bounds. I want to say I want one of these things, and it needs to implement 3 traits. And struct. Yeah. Don't care about this. Don't care about this. Don't care about this. I don't know what it's called. Don't care about the dispatching. Don't care about it. Don't care about traits. Interfaces. Yes. 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 Struct member reference Google Rust reference with multiple trait bounds. Maybe I'd. Yeah. How'd you do it in the structure? Wait a second. I don't think it does go here. This is what I think I'm getting wrong. Part mapping criteria. Maybe we don't derive. Oh, how do we do this? Ah. Should the trait bounds be on the method that I'm trying to do? No, because, well, maybe. I mean, the thing that needs it is this assert, right? Yeah. Mapping expected part. Oh, my brain hurts. Yeah, we know it doesn't. So, where do you specify it? Oh, it was. Oh, wait a second. Let's just make this derive apply to everything to start with. Because this error, because it compiles it twice. I always forget this. It compiles the production code and then it compiles the test code. Right. Is that what it wanted me to do? Oh, no. Is that right? Yeah, okay. So you define a new trait with it. Okay. This is it. This is it. So PMC. And then you say PMC here. Okay. Right. Something like this. PMC cannot be made into an object. Take that off. Right. Because it doesn't have anything in it right now. Right, because there's no methods in the part mapping criteria trait yet. Let's say function match self part. Let's just do this. And it returns bool. You can't use keyword match. Matches. Okay, fine. Building a V table. You can build a V table now, surely. Part mapping criteria. Right, but this doesn't match this yet. Implement methods. Let's just do that. And to do, fine. Oh, it made it into an object. I must be missing something here. Because it uses self as a type parameter. Oh, no. We'll let's open it in the wrong browser. Which is really great. Do I need don't know. Traits that are declared as trait sized or which otherwise inherit a constraint of self size are not object safe. Let me go back to my code a second. Oh, what do we do here? What do we do? What do we do? What do we do? What do we do? A trait cannot be made into an object. Honestly, don't know what to do right now. Could have sworn this was sort of how you do it. I've got a part mapping which uses criteria object. The criteria object has got, it's defined as something which has got stuff in it that I want, and it implements an interface, and I want to call the matches on each of the things. Should this? No. Is this? It's funny. I don't remember this. I mean, this is the same as this, but without this. Right, hold on. Let me just go plus. But this is not how you do it. Yeah, no. Let's just forget that. What's it bitching about here? Fine. What do we do? What do we do? What do we do? What do we do? Let's search for polymorphism in Rust. Sure. Yeah. My approach to this might be because I'm thinking in Java land. Yeah. But it's, I want to struct with a dynamic trait. No. Oh, I could use an enum for it, I suppose, because enums in Rust are a bit more powerful, aren't they? Maybe we should be using enum, actually. Hold on, let me think about this. So we've got our exact matching criteria, which should implement something. No. I don't think that's right. Don't think we want an enum. I don't know. Yeah, it's not that. Traits. Mm-hmm. But say I want a reference to a shape somewhere. This is what I would try to deal with. Yeah. Yeah. Mm-mm-mm-mm. Yeah, I mean, I could define them all as being enum variant, all these different matching implementations, and then when you call match, you go, if it's one of these, then check this if it's one of these. But this ties all the details of how the matching is done to each to one giant enum, which I'm trying to avoid. Um. Oh dear, how do you do it? Um. Um. Yeah, let me go back to this. Let me put this back on for a second. Right. Can't derive this from it, so let's just turn this off. And then it says this doesn't implement debug. Right. Let's just do a impl debug for part mapping just for a moment and try this a different way. F dot write format whatever. Is it right? Rightster. Yeah. Oh gosh. But what are you supposed to return here? I can't remember this. Manually implementing debug. We've got to look. Yeah. Give me an example. Oh, this is it. Finish. What? No. Oh, you just return the formatter? You return OK? No. How do you use this API? Got a formatter. And I need to get a result. But it says you get a result when you call write stir. Boom. Well, what did I have there before? Oh, am I just missing the bracket? No. I've got too many brackets. Oh, I had... there was an extra bracket. I couldn't see it. Let me just see what happens now. Yeah, for part mapping, import. Yeah, okay. I don't care about these right now. We'll... Right. Doesn't implement partial EQ. I don't really want to be implementing partial EQ. Wait, do we... No. I'm thinking of completely the wrong thing. So we can do that, and we can do the same for partial EQ, but we can't write the code that goes in it, really. I mean, we can compare the part, but how then do we compare the... or print out the criteria, unless this has got this on it, and this just adds the trait bounds to it as well. I just want to know how to specify the trait bounds on the dynamic trait. Surely you can build a vtable with methods on each of the things. Brain, no functionality. I've done this before. I can't remember it. I want to like open criteria. Do I specify the trait bounds on the matches method? No, because the matches method doesn't care. It's only the assert that cares about the trait bounds. And only in test land. Part mapping criteria. This is what I want to do. But I don't know how to do it. I don't know how to do it. What are we supposed to do? Let's look more at the... Let's go advanced traits. Right, we can implement things for it, and we can say that the type of thing return is this. This is fine. No. trait. Yes, implementing this for a type, which is fine. I mean, let me just stupidly write impl debug for part mapping criteria. I just want to see what it says. No, I mean, but this is, I just want the default implementation. No, I mean, but this is what we were doing a minute ago, right? Yeah, let me get rid of this. I definitely don't want to do this. Okay, I'm just going to put to-dos in these things and just wait a second. Okay, right. I remember this now. I'm still not sure this is what I want. I mean, it compiles like that, but I mean, what is this? Is that just a recursive thing that I just did there? Not entirely sure. This is probably wrong. I'm fairly sure this is wrong, and I'm doing it completely wrong. But I need to make progress and then come back to it once I work out exactly what I'm supposed to be doing. So we get whatever for the criteria, which is fine. So we can print out stuff. You know, this is slightly better. If we go self dot whatever, the only thing we can call it is matches, right? Because part mapper criteria only has one method on it that you can call. So you can't print it out. So I want to say that I can use multiple traits. I want to be able to use hold on a second. T debug. Is it something stupid like this? Yeah. No. Maybe I've got this. Well, I did. Yeah. Well, I mean, well, that doesn't make sense, right? Yeah, that really doesn't make any sense. How do I do it? Ugh, brain hurts. I'm really struggling with this today. I might have to come back to this. I might have to look stuff up and come back to it. I just want an object which has got vtables from other objects combined into one vtable, so I can call debug or format or partially or EQ on it. Right? The problem is my inability to specify what I want here. This is all rubbish. Let's just get rid of this. It says doesn't implement debug. The trait debug is not implemented for this. And then if I specify which is what I thought I could do, it goes, it's a non-auto trait. This is non-auto trait, additional non-auto trait. Consider creating new trait with all these as super traits, which is what I did. Right? I mean, I thought it was type alias that let you do it, but is it this? Right, and now you get can't be applied to this plus partial EQ, which is what we need to put on here. And then it says can't be made into an object. We're just going to search for more of this error message because the trait blah cannot be made into an object. What I was reading wasn't helping me. It was this error message. I looked at it and it didn't make sense to me. Right. This is sort of what I want to do. Yeah. This is sort of what I want to do. It gives you this. What can you do? How do I fix it? You cannot. Great. What options do you have? I All I want to do is compare two things together in a test. Why is this so hard? Uh, yeah, pretty much what I want to do. Uh-huh. Oh, great. I'm not the only one. Um, hmm. Probably missing the fundamental key bit of information to solve my problem. Don't know, don't know, don't. Yeah, trade object use dynamic. So let's just swap concrete type at runtime, which is what we want to do. All right. Which is fine. That's what I want to do. We need to change it to take self or mutable self as its first item to work. Yeah, I mean, that's fine because it doesn't have this in it. It's fine. But we do this. Partial EQ. Let's have a look at partial EQ. Partial EQ trait takes self and it takes self, right? So specifying trait bound, specifying trait bound. Because it uses self as a type parameter. Right, so it uses self as a type parameter. Okay. Let's see if someone else has run into this. Partial EQ is partial EQ self. So we do self. We don't know. It's whatever the dynamic type is, right? Oh yes, any. Hmm. Let's look at that for a minute. Yes. Hmm. Yes. Think about this. Looking at any documentation. Hmm. Okay. I've been stuck on this for way too long. Um. I'm going to put this back. I'm going to delete this for now. we're going to try and work out an alternative way of doing this assert, because the problem is the assert. Well, there's many problems, but right. Let's go match mappings dot or I don't like this. Let it be known. But I need to move on. Assert EQ mapping dot oh. What? Oh. It's just crap. It's crap. I don't like it. 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 It's just wrong. It's wrong. It's wrong. It's wrong. It's wrong. It's wrong. I'm gonna do it. I want to move on with some of the other things. And this is just bad. No, we can do it here. Fine. Fix me. Want to just do this. Fine, 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 fine. So we got part mapping, part EQ. We've got two things. We want to compare one to the other, and we want to get E. We're gonna get just. I don't really care about the part mappings that we use to do it. What I care about is the parts came back. I mean, I do care about it. And I want to know exactly which mappings we use, but we'll somehow do that later. So match mappings .unwrap.iter.zip with expected part mappings .unwrap.iter. And then we've got matched mapping and then expected mapping. Let me say match mapping dot part equals expected mapping dot yeah, I don't need to do EQ. Okay, well, we can write this. And you know, I don't like it. It's not what I want to do. I want to say, just do it. I want debug. I want the other things on it. Anyway, let us move on. That's a long time on that. Right, match parts. Called unwrap on none. Panicking. Everything's fine. Where? Matched mappings. Right. So, I used the wrong one. Okay, there we go. Assertion failed. That's what we want to see. Right, so we can actually finally now write some other code, and we can come back to this thing at some other point. So what we're trying to call is process, and we're trying to return a list of part mappings. But we made it return none. Right. So what we're trying to do is iterate over the part and filter and map the parts if the mapping matches. And we worked out how to get a part mapping from the mappings list, which is fine. Right. So what we want to say is probably match no. We're going to use the part mappings and we're going to iterate over them. And we're going to filter we're going to try and find the mappings that actually map. So we're just going to do filter to start with. And we're going to go mapping PM. Then we're going to say PM, and we should have access to the criteria. And we're going to say we're going to iterate over each of the criteria. Good Lord. And we're going to filter these by the criteria. And then if the criteria matches, oh dearie me. And if the criteria matches, but matches doesn't take an argument at the moment. It needs to take an argument. It needs to take a part, which is a reference to a part. And there's only one lifetime, so it should work it out. Right, fine. So if it matches the part that we're iterating over, and we're just going to do this naively. No, it returns a Boolean. So that's okay. Oops. Okay. So if this criteria matches, then we're good. And then if we go collect on this, we can go let matching criteria, let matched criteria. This is actually quite a head fuck. And then what have we got? So then we've got right. Right. And then we go match criteria dot is empty. Good lord. Why? Okay, I need to see what the error message is. Matches as one parameter. Right. Let's fix this. Just going to delete it and redo it. Type annotations needed. So criteria. It's probably going to be a vector of in. Well, what are we doing here? Oh, I can't even work out what I'm doing now. Oh dear. Part mapping's got a criteria. Part mapping criteria it's got a method which turns true, and then we're trying to get out. There's a lot of iteration going on here. It's just redonkulous. So we've got parts. Let me just reorganize this so I can see the wood from the trees a little bit. We're iterating over the parts. And then for each part, we need to check all the part mappings. Wait a second. What? My brain hurts. Let's go back to my test. So if we've got 3 parts and 3 part mappings where it's an exact match of the manufacturer name and part number, then this manufacturer and part number goes to this part, and brain really hurts now. Then I want each one of these to be listed, and I want to know what mapping was used to find it. So we go over each of the parts, and then we look at the part mapping and see if it applies to the part that we're looking for. So We go over the parts, we've got a part. Then we go over the list of mappings, and we start with the first one. And the first one has got a list of criteria which could be applied to it. And then if that criteria does apply to it, then we want to reduce. Don't we want to reduce this or something? We just essentially want to. Hold on. Because we just want to. Well. Okay, let's. What's the definition of criteria here? Criteria is this. Let's just use that here. Yeah. And we have this clone thing here as well. Fine. So then we return a Boolean. So now Boolean if any of the criteria cause the part mapping to match. Right. So now we've got a filtered list of part mappings that applied. Right. So part mappings is defined as this. So because it's bitching about the collect thing, we're going to put this in here and use that lifetime, which is fine. And it also bitches about this problem. So we're going to do that again. Right. And it compiles now. So bar is the list of matched mappings now. And foo is the is nothing yet because we haven't done anything with the matched mappings. Matched mappings, okay. So if the match mapping is empty, what are we trying to do? We're trying to return the part mappings. That matched. But we need to return this now. But this is only doing one part mapping, but we've got multiple part mappings that match. Yeah. Yeah, because this is so we've got the part part mapping. But this would give a part. Yeah. Because here we're returning a vector of stuff instead of one. Oh God. I shouldn't say God. I should say gosh, really. But there we are. Well. Well. Well, I don't know. It, I'm iterating over the wrong thing to start with. I think I am. I think this is the problem. Because I initially decided that I wanted parts back from this, but I actually want part mappings back from this. So I think this is where the problem is. Let's invert this. We don't have part here now. And don't worry about it being woefully inefficient. Is this going to do the right thing anyway? No. 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 We want to iterate over the parts. Let's do this a slightly more naive way. Let result is, which is going to be a vector of part mappings equals vec. There is probably a better way of doing this. I can't see the wood from the trees right now. There probably is a way of doing this. I'm going to just park all this for now. We're just going to do for part in parts. And then we're going to go for part mappings in, for part mapping in part mappings. Honestly, I try and use these chained filtering map stream things and stuff, but it just hurts my brain. And then we're going to go for each. Why is it moaning about this? oh well, dot iter. Part mapping. And then we're going to go for criteria in part mapping dot criteria. Then we're going to go if criteria dot matches part results dot add push in Rust the part mapping. No. Like just filters, mapping, all the rest of it. Okay. Right. So, we're calling matches. We haven't implemented this yet. Exact match criteria. Let's do a new test. For this specific criteria. I mean, hash bracket. Oops, daisy test. Okay, but moving on. Fun matches. When criteria matches art I just realized what might be the problem. Do no, we're okay. So criteria. Let criteria. Yeah, and then other criteria would be like regular expressions to do the same thing, right? So everything's fine, yeah. Okay. We don't have a part. Okay. Huh? And we have to use the trait and the pass a reference to it. And then we're going to run just these ones. It's not implemented, which is fine. So we're going to go self.manufacturer equals part dot part dot manufacturer. and self.mpn equals part.mpn. Now, you can imagine a regular expression of implementation looking, why is it, it's on the brackets? Why is it moaning? Oh, no. Yeah, fine. Everything's good. Right, it obviously matches, which is good. We'll have another test. Does not match. And then again, I want a parameterized test. Does not match. So we're going to have different manufacturers, but the same part. And then we're going to have part MPN difference. And we're going to say it doesn't match, and it doesn't match. Oh. Yeah, that thing is weird. You put it in the right place and then it moves it. Right, so we can match things. Everything is fine. So let's go back to our part match test and see what happens now. I mean, it's some match mappings. So process is still returning none here. But if our results, right. So match result dot is empty. True? Is it this? Am I doing the match thing right? I forget. None. False goes to some results. Oh, amazing. We can match parts. That's we due to in part mapping. Great. It might be useful to print some things out just to get some visualization on this. Da, da, da. And we put it up before the assert. Okay, so run it again. And this is what we get. So from our list of input parts on the left, from our list of parts, wait a second. No, that's not what we really want to print out. Matched mapping. Yeah, we only need this, don't we? Getting ahead of myself, I think. So. And let's just see if the debugger works while we're here. So matched mapping is this one. And it has criteria, yeah, which is our dynamic thing. Can we look at the? Can we look at this from here? Not sure if we can. No, we can't because it's only got the v table. It can't look at the object that it refers to because it's only using the interface for it, which kind of makes sense. Yeah. Okay, so fine. Right. We've been going quite a while now. It's 5:30. So I think I'm going to call it there for today. Definitely have made progress, but yeah, slow going. Slow going, much to do. All right. Yeah, so it's only software. How hard can it be? See you on the next one.